Hey you guys, welcome back. Today we're going to go over simplifying fractions. Before we do that though, food review number 13. Today we have Trader Joe's Deli Sandwich Potato Chips. I haven't tried these yet. The other day I went into the closet over here in the classroom and I was like, oh, I got chips, great. I opened them up and I remembered, oh wait, I was going to do a food review of these. So I'm waiting till now to try them. So these are supposed to taste like a ham and cheese sandwich or a turkey and cheese sandwich. It also has like a sandwich on the bag over here and a pickle over here. It's like the combination of that and a chip. So let's go and try these. These are kettle cooked, which are always my favorite. So let's get one out of here. In case you want to see what it looks like, chip. All right. That is delicious. Oh my gosh. Wow. It actually really does taste like a deli sandwich. And you can really taste the pickle in there too, like the vinegar kind of bite. Super crunchy. They're not stingy with the seasonings. You know how some chips, they don't put a ton of seasoning on there? These are amazing. Wow. I have one more before we go on. Wow. Good on Trader Joe's. It's incredible. All right. So, food review of the day. 10 out of 10. Buy these. Not 10 out of 10. 8 out of 10 for sure. Delicious. All right, so food review of the day done. Let's go ahead and get back into the math. Let me move this out of the way, make this a little bit smaller. All right, get this over here a little bit. There we go, perfect. All right, so we're gonna talk about simplifying fractions today. Simplifying fractions is all about making whatever numbers we start with in our fraction smaller. So let's go ahead and get started. Activate the pen. Wait, let me go over here and click it 1 second. There we go. All right, so whenever we have these, we have 4 over 12. We want to make a simpler fraction, and we want to make those numbers smaller. So the way we do that is we're going to go and find this right here, the GCF. What's great is a lot of you guys probably remember that 3-letter phrase, GCF. We hear about it a lot. And you guys have done fractions for a while, so you probably heard about it for a few years. What that means, what that stands for, is the greatest common factor. So we need to go and find the greatest common factor of 4 and the greatest common factor of 12. So a lot of you guys are really smart. You could probably do this in your head, but in case you forgot, or in case you just want a more extensive and thorough review, I'm going to write the factors of 4 and then the factors of 12. The factors of 4, and a factor is just those small numbers that go into a number. So for instance, what numbers go into 4? Well, 1 and 4, those are factors, and then 2 and 2. And I always write factors in factor pairs. So 1 and 4, I know those are factors because I can multiply 1 times 4 to give me 4. Same thing over here, 2 and 2. 2 times 2 gives me 4. So I always put them in a pair because when they're in a pair, I'm a little less likely to forget one. Sometimes when you're writing them out and trying to do them in order, just thinking off the top of your head, it's easy to forget one and leave one off the list. So do it in pairs and you won't forget one that way. The factors of 12, we have 1 and 12, of course. We have 2 and 6. We have 3 and 4. And that's all of them. So I'm going to go and see which one is the greatest common factor. Which number is the largest that they have in common? Right here, it's a 4. So once I find the GCF, I'm going to go and divide the numerator and the denominator by that GCF. So 4 divided by 4 gives me 1. 12 divided by 4 gives me 3. So my simplified fraction is 1/3. If you can simplify a fraction, you must. All right, that has to be your final answer, the simplified fraction. Let's look at the next one, 7 over 14. Once again, we got to find the GCF, the greatest common factor. So I'm going to go and list out the factors. I have 7. I have 14. The factors of 7, what numbers go into 7? 1 and 7. And that's actually it. That's all that go into 7, 1 and 7. 14, 1 and 14. Notice the pattern, how we're always starting with 1 and the number itself. 1 and the number itself. Those are always the first two factors I'm going to list. Then for 14, I got 2 and 7, and that's it. That's all that goes in there. So the greatest common number is a 7. So I'm going to go up here. I'm going to divide both the numerator and the denominator by 7. And I'm left with 7 divided by 7 just gives me 1. 14 divided by 7 gives me 2. So I'm left with 1 over 2, or 1/2. Let's look at the next one, 6 over 8. Same thing, go and find the greatest common factor, the GCF. So I'll write out the factors of 6. I'll write out the factors of 8. So the factors of 6 are going to be 1 and 6, and then 2 and 3. The factors of 8 are going to be 1 and 8, and 2 and 4. So now, let's see which number they both have in common. Oh, it's a 2. So I'm going to go and divide both the numerator and the denominator by 2. And I'm left with 6 divided by 2. Let me write the answer out here. 3, 8 divided by 2, 4. So that's my simplified fraction right there, 3/4. Let's look at the next one. Now, the only difference between 7th grade and the other grades when you do fractions is that sometimes in 7th grade, some of those fractions are going to be negative. There are 3 different ways you can write a negative fraction. You can either have the negative sign in the numerator, like this problem here. You can have the negative sign in the denominator, like this one right here. Or you can have the negative sign actually with the fraction bar, like this out here. Now, I don't suggest this third option, mostly because some kids, if they try to do it with the fraction bar, they'll write it and it kind of looks like a part of the fraction bar. And that's not helpful. You forget that it's a negative fraction, and then you can make a mistake that way. One of these is usually the most common options, and this is probably the most universally accepted option, putting it in the numerator. That's what I always do. But you could see any of them on milestones or on a test or on a quiz, because technically you can write it any of those 3 ways. So whenever I'm going to find the greatest common factor here, so I can simplify, I'm going to do everything the exact same way. Oh, let me get the eraser and move that out of the way. Oh my gosh. There we go. Now I'm going to do everything the exact same way. I'm just going to ignore the negative sign there. I'm still going to find the factors of 2 and the factors of 20. So the factors of 2 are 1 and 2. The factors of 20 are 1 and 20. Notice I'm still doing it in a factor pair so I don't forget any. 2 and 10, and then 4 and 5, and I believe that's it. The greatest common factor here is 2. So I'm going to divide the numerator by 2 and the denominator by 2. And now, this is where it's important to know those negative rules. Negative 2 divided by 2 gives me a negative 1. 20 divided by 2 gives me 10. I'm left with negative 1/10. So another way to think about it is if we start with a negative fraction, we're going to end with a negative fraction. Because all we're doing is make the numbers smaller. We're not changing it from positive to negative. Let's look at the next one. Negative 9 and 12. Again, I'm going to find the GCF of 9 and the GCF of 12. I'm going to ignore the negative when I'm trying to simplify. So the factors of 9 are 1 and 9, and then 3 and 3. And I always write it in factor pairs, so I always have 3 written twice. If you just write it once, that's also good too. That's fine. Factors of 12 are 1 and 12, 2 and 6, 3 and 4, and I believe that's it. Yep, that's it. So the greatest common factor here is going to be a 3. Oh my gosh, this is going to be a 3. So I'm going to go divide the numerator by 3 and divide the denominator by 3. And now I'm left with negative 9 divided by 3 gives me negative 3. 12 divided by 3 gives me 4. I'm left with negative 3/4. I started with a negative fraction. I'm going to end with that too. So let's look at the next one, negative 14 and 18. So the factors of 14. So I'm just going to ignore the negative for right now and just do everything the same that I've done so far. We have 1 and 14. We have 2 and 7, and I believe that's it. Yep. 18, I got 1 and 18. I have 2 and 9. I have 3 and 6, and I believe that's it as well. Yep. The greatest common factor here is going to be 2. So I'll divide the numerator by 2 and the denominator by 2. And I end up with negative 7 over 9. Start with a negative fraction. I ended with a negative fraction. Let's scroll down. I'm going to have to give this an erase. Look down the next set. All right. Move this back out of the way. So now I have negative 3 over 9. Same thing. I'm going to go through and find the greatest common factor. Factors of 3 are 1 and 3, and that's it. Factors of 9 are 1 and 9, 3 and 3. And again, I always do in factor pairs, all right? Even if I write the same number twice, I'm just confident I won't forget any that way. So the greatest common factor here is going to be a 3. Let's go divide the numerator by 3 and the denominator by 3. I'm left with negative 1/3. The next one, 15 and 45. Now, those are pretty large numbers. One thing that you can do here, I could write out the factors of 15 and the factors of 45, but there are probably a good few out there. Like, I don't want to write all those numbers. One way to always think about this is if that top number, the smaller number, can go into the denominator, and I mean by that, can 15 go into 45? Let's see, 15, 30, 45. Oh, it goes in there 3 times. Let me give that an erase. So if it can actually go into that number, then I know 15 is the greatest common factor here. So I'm going to divide both of these by 15. Negative 15 divided by 15, oh, that's just negative 1. 45 divided by 15, oh, that's 3. So sometimes you can take a quick little shortcut like that, and it works out if the top number actually goes into the denominator. Look at the next one. Negative 10 and 32. Again, I could write out all the factors of 10 and 32, but that might take a minute because there's a good few. You know what? Instead, I can also take this in steps. I know they're both even. I know no matter what, 2 goes into both of them. They both have a greatest common factor of 2. Let me go and do that first. Negative 10 divided by 2 is negative 5. 32 divided by 2 is 16. And then I'm going to think, does 5 and 16, do they have a number in common? They don't. So I'm going to leave it there. There's nothing else that they could do. I can't make those numbers any smaller. There's no greater common factor. Over here, 9 and 21. Again, sometimes in your head, you're going to start really getting the hang of this and be able to do this in your head. The greatest common factor of 9 and 21 is going to be 3. 3 goes into both of those. I'll divide them both by 3. I'm left with 3 over negative 7. And you can leave it like that, or you can put the negative with the numerator like this. And honestly, that's what I'm always going to do, because that's kind of my habit. I always leave the negative with the numerator. Over here, same thing. The negative is with the denominator, but we treat it all the same. And this is one of those problems like we had a few minutes ago. If that numerator can actually go into the denominator, then that's going to be the greatest common factor. 10 can, of course, go into 10, and 10 can also go into 70. So I know my greatest common factor here is going to be 10. It can't be any number larger than that, because any number larger than 10 wouldn't go into 10. So 10 is the biggest number I can have there, the greatest number I can have there. So I'm going to divide both of these by 10. I'm going to end up with 1 over negative 7. Or if you wanted to move the negative to the numerator, you can also do that too. Either one is correct. 5 and negative 35. Again, same thing. Can the numerator go into the denominator? If it can, that'll save you a lot of work. 5 does go into 35. So I know that 5 is the greatest common factor. I'll divide both of them by 5, and I'm left with 1 over negative 7, or negative 1/7. Oh, same answer as the last one. This one down here, now this one is 2 and 7. If I went and wrote out all the factors of 2 and 7, notice how there is no GCF other than 1. If it's a 1, we can't make those numbers any smaller, because I would just divide both of these by 1 and end up with the same exact fraction. In this case, this is not actually a negative fraction. It sure looks that way because there's 2 negative signs, but every fraction is like a division problem, and when we divide a negative number by another negative number, we get a positive answer. So all we're looking for here is negative 2 over 7. Negative 2 over negative 7 should be positive 2 over positive 7. That's what we're looking for there. All right. Over here, same idea. 2 negatives in a fraction, that really means this fraction is a positive fraction. It's not a negative one. Let's go write the factors out. Or you know what? Again, same thing. Can the numerator go into the denominator? 4 into 8? It sure can. So that means that numerator is the greatest common factor. Divide by 4. Divide by 4. And I end up with 1/2. Positive 1/2, because this started with 2 negatives, which really is a positive fraction. So simplifying fractions, all we're looking for is the GCF, the greatest common factor. Find it, and then divide the numerator and the denominator by it. So thank you guys for sticking around for the whole video. I'll see you guys in class tomorrow. Bye.